Okay, greetings everybody. Hope everyone's doing okay. We'll get started. It might take me just a second to get everything rolling here, but hopefully it won't take too long. Maybe it'll be fairly quick. So you should be able to see my screen, and I should be recording as well right now, as of right now. So let me hit File, New Tab. That would be great. And let me, so this is Screencast-O-Matic, and it shouldn't kick me out. Let's get rolling with it. I'm going to check back after 15 minutes just to make sure. So this is statistics. Let me log back in and all that good stuff. D2L. And we'll get here as soon as possible. So, well, looking at what's going on here, let's go to content, but I need to go to Connect Math. There's just so many little places I gotta log into. That's okay. Let me do that. Now, last time's video we covered quite a bit. I didn't cover all that I wanted, so now we'll get to cover that now. Now, let's go to 4.4, and I'll preview 4.4. And let's go about that business now. Now, remember from last time, the number of ways to arrange 11 different video game cartridges. It is, it's 11. Well, let's look at this view, the sample question. I have my own way of doing this, truth be told, but I'll humor them. How many different ways can 13 video game cartridges be arranged on a shelf? Use a graphing calculator, and you will need a calculator, to be honest, even doing it my way. 13 NPR 13. Now, we're going to need NPR, don't get me wrong. This one, there's an easier way. 13 NPR 13, it's a big number. It's this number right here. You could spend your lifetime arranging these. What is it? It's like 6 billion. Let me turn this cell phone down. 6,227,020,800. Yeah, you could spend your entire life just rearranging 13 particular video games on a dusty shelf. You know, that's probably not the way you want to spend your time, but anyway, it's amazing you just get that from 13 video games. But what's really wild is, you know what this really is? It is 13 factorial. Now, with 13 with an exclamation mark out of it, or I mean beside it, to the right of it. But what does that mean? That's 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6. All these mean the same thing. Times 5 times 4 times 3 times 2 times 1. And well, we should trust me. It works. 13. I wish Google would have cooperated. it wants this notation, I think. 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 and times 1. Well, it doesn't. We're really done, but so there it is. Same thing. Now, here's the thing. It would be great if it would let me pull up Microsoft. So I'm going to try. It won't let me open up a new document. Well, that's a pity. Excuse me. Let me, I can go to Google Docs. But now, what it is we define 13 factorial to be this thing right here, right? We define 13 factorial to equal 13 times 12 times 11 times 10 times 9, all the way down to 1, times 8 times 7 times so on. Right? Oop, and that 1 I meant. Okay, so we define it that way. And in particular, well, that's true of that's not only true of 13. That's true of any number. Well, the analogous thing is true. Well, you know, if you use somebody else in 13, you got to accommodate that somebody else. Like if you do 7 factorial, that would be 7, 6, 5, 4, 3, 2, 1. 7 times 6 times 5 times 4 times 3 times 2 times 1. That would be, check it and see if you get, I memorized it. It's 5,040, 5040. And it would be great if I could get Google Docs and we could do a few little examples. That would be awesome. I don't have a Microsoft on this computer, which is that's the pits. Oh well. Is what it is. Well, what was this guy back here? Let me pull this thing up. Here we go. This looks awesome. Well, let me just add on to this. This is a Google Doc. Now we define, we'll get to the other stuff in a minute. Just hold up. We define n factorial to equal n times n minus 1 times n minus 2 times n minus 3 times yada yada yada, all times 3 times, all the way down to 3 times 2 times 1. For example, we define, let's do some examples. We define 5 factorial to equal, well, 5 times 4 times 3 times 2 times 1. That's 120. Check it and see. Now, if we divide 5, you know, if we divide all sides by 5, that's 4 factorial. Because, and indeed, I'm dividing everybody just by 5. That's just going to leave me with 4 times 3 times 2 times 1. And 4, 3, 2, 1, 4 times 3 times 2 times 1. That's check it and see that you get 24. And check it and see that 120 divided by 5 is indeed 24. Now, if I take this thing right here and divide all 3 sides by 4, I cut down to 3 factorial. That's just 3 times 2 times 1, and that equals 6. Now, check and see if I divide all three of these sides by the number 3, I get 2 factorial. That's 2 times 1, and that's not exciting. That's just 2. Now, if I divide all 3 sides of this thing by 2, I get 1 factorial. That just leaves 1 behind. That's it. Well, but what if I divide both sides by 1? Can I do 0 factorial? Yes, I can. It's fine. But now the buck stops there. I can't divide by 0. We we cannot define the factorials of the negative integers. We can extend the factorial in other ways, but we can't, if we use advanced math, but we can't extend it to the negative integers. They're stubborn. But let's move along. So that's factorial for the negative integers. Now, now here's the thing. What if I want to, what does it mean? Let me arrange, how many ways can I arrange 5 football players in a single file line? Let me just call them Andrew, Bobby, Carl, David, Eddie. Well, the answer, how many ways though? The answer is 5 factorial, and that's 120. For example, you could have Andrew, Bobby, Carl, David, Eddie, or you could have Andrew, but you could have this, or you could have Bobby. You could have something like Bobby, David, Carl, Eddie, Andrew. Right? There's all sorts of things you could have. The order you put these football players in, in a single file line, right? Now, if you're going to go listing them, the best thing to do is to be systematic about it, like A, B, C, E, D, and then like that, and then maybe move the DE and ED around, like maybe do A, B, and move the DE one over, put C over here, and then move the DE over here, and move, and that pushes B over. Move DE over here. That pushes. You got to be real systematic about it. But I'm not going to list all these, and then so on and so forth, so on and so forth. There will be 120 of these. I don't feel like doing them all, right? And indeed, this would be one more down here, but so there, 5 factorial is 120. But what about 3 secretaries or 3 CEOs in a line, in a single file line? Let's say that I have Janet, Susan, and let's just say Janet, Susan, and Wilma. Well, now these I can list. It's going to be 3 factorial, but that's only equal to 6. So we can do that in a same period of time. Janet, Susan, Wilma. Janet, Wilma, Susan. Then I can scoot over Susan, Wilma, Janet. I can do Wilma, Susan, Janet. Now, what about the cases where Janet comes second? Wilma, Janet, Susan, Susan, Janet, Wilma. And that's all 6, right? That's what factorial does for you. It gives you the arrangements. And it gets big fast. Note that factorial, we call the exclamation mark factorial, gets big quickly. For example, 100 factorial is very, very big. 100 factorial is quite big, is insanely big, right? Is very, very big, right? It would be 100 times 99 times 98 times 97 times 96 times yada, 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 all the way down to 1. That's crazy big, right?